Okay, good afternoon, everyone. For today's discussion, I am going to discuss to you the learning activity sheet that was given to you last distribution. You have with you your learning activity sheet number 1 and the learning activity sheet number 2, or you have the worksheet number 1 and the worksheet number 2. So for today, we are going to discuss first the last one, or the worksheet number 1. Actually, by the way, this is the first lesson for your third quarter. Pag hindi clear po yung audio ko, pwede kayong mag-chat. Pag masyadong mabilis yung discussion, pwede kayong mag-chat. Or if you have any question, mag-chat lang po dito. Okay, so let us proceed. Okay, so for today's discussion, the most essential learning competency is that the learner solves problems involving permutation. So ito yung competency natin. The objectives are illustrate permutation of object, solve problems involving permutations, circular permutations, and distinguishable permutations. Okay, so let us start. Our topic for today, by the way, is permutations. So we have here the definition of permutations. Sabi daw, andyan ito po, nandyan yan sa hawak nyong learning activity sheet number 1. Now, we have here the definition of permutations. It refers to the different possible arrangements of a set of objects. The order of objects is important. So take note, sa permutation, there is an arrangement. And ito ang pinaka-importante. Sa permutation, the order of objects is important. So ano ibig sabihin nito? Meron tayong permutation and combination na topic ngayong third quarter. So for permutation, itong sinasabing the order of objects is important. Say for example, you have A, B, C, D. Ito yung order niya. First si A, followed by B, C, D. This is different sa arrangement na B, C, A, D. We have here two different permutations. Now, pag pumunta tayo sa topic na combination, ang A, B, C, D, this is just the same sa B, A, C, D. Kaya, magbibigay ako ng konting background sa combination, kung bakit sila pareha. Magiging pareha sila since they are using the same letters. We have here A, we have B, we have C, we have D. Sa combination, parehas lang yan. Although, magkaiba ang arrangement. They are just the same. Pero when it comes to permutation, kahit pareho ang object na ginamit, or in this case, parehong letters ang ginamit, pero magkaiba ang arrangement, magkaiba po itong dalawa. That is what we mean by permutation. Okay. Ano yung mga real-life example ng permutation? Halimbawa ngaya, CP number. Halimbawa, 0, 9, 1, 2, 3, 4, 5, 6, 7. 0, ilan na? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ganyan. This is different sa number na 0, 9, 1, 2, 3, 4, 5, 6, 7, 1, 0. Although they have the same number, pero yung last two digits, magkaiba yung arrangement, magkaiba itong CP number. That is an example of permutation. Okay. We have here example number 1. A close friend invited Anna to her birthday party. Anna has 4 new blouses. She has stripes with ruffles, long sleeves, and sleeveless. And she also has 3 skirts. She has red, pink, and black in her closet reserved for such occasion. Assuming that any skirt can be paired with any blouse, in how many ways can Anna select her outfit? Now, ilan ang possible outfit na pwedeng maisuot ni Anna? Take note, si Anna, meron siyang 4 na blouses, 3 skirt. So, ilan ba ang possible? So, halimbawa, napili ni Anna is stripes. Yung blouse ni Anna is with stripes. So, pwede yan i-pair sa red. Ito, blouse na stripe, red na skirt. Isang, ano na yan, one possible outfit na yon. Pwede rin naman na stripe ang suot ni Anna and then pink yung skirt niya. Another possible outfit. Pwede rin na stripe yung suot ni Anna and yung skirt niya is black. Another, ang tawag dito, another possible outfit. Now, the question is, how many ways can Anna select her outfit? How many possible outfit ang pwede niyang pagpilian? So, dito may na-example na akong 3. This is stripes lang. Now, how about with ruffles? Now, kung with ruffles, ang blouse niya, pwede rin niya itong partneran ng red skirt, pink skirt, or pwede rin na black skirt. So, dito sa stripe, meron siyang 3 possible outfit. 3 possible outfit din sa with ruffles. Now, sa long sleeve naman, pwede niya itong partneran ng red na skirt, pink na skirt, or black na skirt. Pwede rin naman mapili ni Anna yung sleeveless. Pwede niya rin itong i-pair sa red na skirt, pink na skirt, or sa black na skirt. So, dito sa long sleeve, meron siyang 3 possible outfit. Sa sleeveless, meron din siyang 3 possible outfit. Now, ilan lahat ang possible outfit na pwede niyang pagpilian? So, as you can see, we have here 3 plus 3 plus 3 plus 3. So, all in all, there are 12 ways Anna can select her outfit. In other words, meron siyang 12 na outfit na pagpipilian. This is using the tree diagram. Ang ganito, this is tree diagram na tinatawag natin. Meron din tayong tinatawag na fundamental counting rule na tinatawag sa pag-solve ng ganitong problem. So, if you're going to solve this problem using the fundamental counting rule, not itong tree diagram, ang gagawin nyo lang is how many blouses are there times, or the number of blouses times the number of skirts. That is the number of ways Anna can select her outfit. So, Anna has 4 blouses times she also has 3 skirts to choose. 4 times 3 is 12. So, there are 12 ways Anna can select her outfit. Ito, parehas nang na-solve natin dito sa tree diagram. This is using the fundamental counting rule, and yung nasa taas, this is tree diagram. Bibilangin mo lang yung number of object times yung another number of the other object. So, all in all, we have 12 ways. Okay, another example. Suppose you secured your bike using combination lock. Later, you realize that you forgot the 4-digit. Nalingawan mo su PIN code. You only remembered that the code contains the digits 1, 3, 4, 7. How many possible codes are there? Repetition is not allowed. Take note, repetition is not allowed. So, ito, meron tayong combination lock. Yung may mga number baga na parang padlock. Tapos, it has 4-digit code. Nakalimutan mo daw yung 4-digit code. Ang naalala mo lang, meron siyang number na 1347. Now, how many possible codes are there if repetition is not allowed? Pag sinabi natin repetition is not allowed, hindi pwedeng maulit si 1, hindi pwedeng maulit si 3, hindi pwedeng maulit si 4, and si 7. Halimbawa, 1, 1, 1, 1. Hindi yan pwede kasi naulit si 1. Hindi din pwede na 1, 3, 4, 1 kasi naulit din si 1. Hindi ito kasama sa counting. Now, meron tayo dito listing method. So, nakalist dito lahat ng possible code. We have 1347, 1374, 1473, and so on and so forth. Nalist na dito yung possible code using 1347 na walang nauulit na number. Kung titingnan nyo isa-isa, wala dyan na naulit na number. Ang makikita nyo lang dyan, isang 1, isang 3, isang 4, isang 7, each code. So if you're going to count the number of codes, we have here 24 possible codes. This is using the listing method. Now, paano natin gagamitin or paano natin isosolve itong problem using the fundamental counting rule? Gaya kanina, ito. This is the fundamental counting rule. Now, pag ganito yung problem, you're going to use 4 digits. So ito, 1, 2, 3, 4. Without repetition. Halimbawa dito, you have here, ang gagamitin mo, 1, 3, 4, 7. Sa first digit, which of these numbers ang pwede mong gamitin? Pwede ba si 1? Pwede ba si 3? Pwede ba si 4? Pwede ba si 7 sa first digit? Lahat ng digit, pwede yan dito. So, meron kang 4 na choices. Now, sa second digit, since repetition is not allowed, yung nagamit mo ditong digit, hindi mo na pwedeng gamitin dito. So, meaning, 3 na lang ang pagpipilian mo dito. Suppose, si 1 ngaya digde, si meaning 3, 4, 7 na lang ang choices mo digde sa second digit. So, 3 na lang. And, for the third digit, nagamit mo na yung isa sa una, isa din sa pangalawa, so meaning, meron ka na lang na 2 pagpipilian. So, 2 possible ways. Then, the fourth one, nagamit mo na yung isa, pangalawa, pangatlo, isa na lang ang choices, ang choice mo. Now, all in all, 4 times 3 times 2 times 1. So, this is 4 times 3 is 12, times 2 is 24, times 1 is 24. There are 24 possible codes in this example. So, this is using fundamental counting rule. And this is listing method. Now, how about niya, madam, if repetition is allowed? Meaning, pwedeng maulit si 1, pwedeng maulit si 3, pwedeng maulit si 4, pwedeng maulit si 7. Now, if repetition is allowed, using the same problem, so we have here 4 digits. Now, sa first digit, ilan ang choice mo? Pwede bang gamitin si 1, si 3, si 4, si 7? Lahat yun pwede gamitin. So, meron kang 4 na choices. Sa second digit naman, lahat ba pwedeng gamitin? Yes, kasi nga repetition is allowed. 4 pa din ang choices mo. The same with the third digit and the fourth digit. So, all in all, 4 times 4 times 4 times 4 that is equal to 256 codes if repetition is allowed. If repetition is not allowed, meron lang tayong 24 codes. This is using the fundamental counting rule. Sana clear yung pakaka-discuss ko nitong on how to solve this kind of problem using the listing method and using the fundamental counting rule. Okay, let us proceed. So dito tayo sa permutation, yung main topic natin. So we have here example number 3. Suppose we have 6 different potted succulent plants and we wish to arrange 4 of them in a row. In how many ways can this be done? So meron kang anom. Halimbawa, ini ngaya. 1, 2, 3, 4, 5, 6. Meron kang 6 na succulent, potted succulent plants. 4 lang digde ang gusto mong i-arrange. Halimbawa, ngayon may laagan ka. 4 lang ang kasya digde. Halimbawa lang ha, 4. How many ways can this be done? Halimbawa, iningiya si succulent 1, si succulent 2, si 3, si 4, si 5, si 6. How many possible arrangement? How many ways can you arrange? So, pwede ang mapili mo digdi si succulent 1, 2, 3, 4. Pwede mo siyang mapili na ilalagay dito. Pwede din mong mapili si succulent 2. Halimbawa, pwede mong mapili dyan si succulent 1, first, second, third, and fourth. Itong 4. Pwede rin mapili mo si 2, si 3, si 4, and si 5. Pwede rin mapili mo si 3, si 4, si 5, si 6. Pwedeng si 1, si 4, si 5, si 6, and so on and so forth. Now, in how many ways can this be done? Okay, balik tayo dito ha. Ang tree diagram po and the listing method, ginagamit lang yan pag very low ang number of objects. Halimbawa, 4 lang, 3 lang, 2 lang. Pero pag medyo madami na, itong 6, madami na ito, it will take time na magti-tree diagram pa kayo or magli-listing method. Now, how many ways or how many arrangement are there? Okay. So sabi dito, we can determine the number of ways these plants can be arranged in a row if we arrange only 4 of them at a time. So sabi bagay dito, 4 lang i-arrange na. Ang i-arrange, 4 out of 6 lang ang i-arrange natin. Each possible arrangement is called a permutation. So ito, one permutation ito. Okay. The permutation of n objects, ang n dito is the total number of objects. So in this case, what is the total number of potted succulent plants? So we have here 6 or 6 taken R at a time. Ang R dito, ilang object ang i-arrange mo per arrangement. So in this example, ang per arrangement natin is 4. So your R or the value of R is 4. The permutation of n objects taken R at a time is ang pagbasa nito, n permutation R. Ganyan. N permutation R is equal to n factorial divided by n minus R factorial. And dapat daw ang n, ang value ng n mo dito is always greater than or equal to R. Hindi pwede na mas mababa ang number ng n compare sa R. And the permutation of n objects taken all at a time is n permutation n is equal to n factorial. Mamaya i-discuss ko kung ano ito na n factorial. Ang pagbasa niyan, itong exclamation point, hindi mo yan babasahin ng pasigaw. Po, ang pagbasa niyan is n factorial. Later, i-discuss ko how to simplify itong factorial. Ito na. N is the total number of objects. R is the number of objects used in every arrangement. Okay. So, ito yung example natin. Example 3. Yung suppose we have 6 different potted succulent plants and we wish to arrange 4 of them in a row. In how many ways can this be done? So, sabi natin kanina, yung total number of object natin, which is N, is 6. And the number of objects per arrangement is 4. So, we have here 6 permutation 4. In other book, we have here na ganitong symbol, pwede rin ganitong symbol. Sa calculator, if you're pag mag-i-input kayo, ganito yung lumalabas. 6 permutation 4. You can use calculator. Hanapin nyo dyan yung P, yung NPR. I-input nyo yung 6 permutation 4. Then, automatic lalabas yung answer. So kung walang calculator, ang gagawin nyo is mano-mano na pag-solve. So, 6 permutation 4, ang formula natin ng permutation is equal to n factorial over n minus r factorial. Ito. Okay, let us substitute. Ang n natin is 6, that is 6 factorial over, ang n natin is 6, ang r is 4 factorial equals. So this is, ang 6 factorial, so mag-i-start ka sa 6, kasi 6 yun nandito, times 5, times 4, times 3, times 2, times 1. Start ka kung ano ang nanditong number, multiply mo yan sa mga susunod na number niya, yung pababa hanggang umabot ka sa 1. That is how to simplify 6 factorial. Now, 6 minus 4 factorial is 2 factorial. Okay. Ang 2 factorial, this is just 2 times 1. So, pwede natin i-cancel itong 2 times 1 tsaka yung sa baba na 2 factorial. So, ang matitira sa taas, 6 times 5 times 4 times 3. So, let us simplify 6 times 5 times 4 times 3. That is 360. So, meaning, there are 630 ways that you can arrange 4 succulent potted plant in a row. That is using the formula. Yan. Kung titingnan nyo, yung sa module nyo, or sa worksheet number 1, ang nakalagyan, therefore, there are 360 ways to arrange the plants. Okay. Next. Okay. Meron tayong tinatawag na distinguishable permutations. Sabi daw dito, it refers to the permutations of a set of objects where some of them are alike. The number, take note ha, some of them. Ito yung clue word dito. Some of them are alike. Kung sabi ko, may magkaparehas na object. May nautro na object. The number of distinguishable permutations P of an object where P objects are alike, Q objects are alike, R objects are alike, and so on is given by P equals N factorial over P factorial times Q factorial times R factorial and so on and so forth. So, anong ibig sabihin yan? Halimbawa ito. Find the number of permutation of the letter of the word is statistics. Now, if you're going to find the permutation of an object, you have to see first if there is repetition of object. Tingnan mo kung may mga nauulit ba. So, in this case, since ang permutation natin na gagamitin is the permutation of the letter of the word statistics. As you can see, sa mga letters, kung titingnan nyo, may mga naulit. Naulit yung S. We have 3S. Meron din tayong T, 3T, and we have I. We have 2 I's. Yan yung mga objects na alike. Now, how are you going to simplify this permutation? So, hindi na natin, pag ganito yung object, may mga nauulit, hindi natin gagamitin yung formulang ito. This is for linear permutation. Ang gagamitin yung formula is itong sa distinguishable permutation. Ito. Now, paano ba yan? That is n factorial, meaning ilang letters lahat-lahat ang nandito. Total number of letters. Kung bibilangin natin, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is 10 factorial. Now, ano yung mga naulit? We have S, T, and I's. Ilang S ang naulit? Tatlong S. Ay, sorry. We have here tatlong S. So, 3 factorial. Tatlong T, and tatlong I. Equals. So, pwede na natin i-simplify. So, you can start from 10 times 9 times 8, 7, 6 times 5, 4, 3, 2, 1. And divided by 3 factorial, 3 times 2 times 1 times 3 times 2 times 1. Yung 2 factorial, that is 2 times 1. So, para ma-lessen yung number, pwede tayo mag-cancel. I-cancel ko na to si 3 times 2 times 1, tsaka itong si 3 times 2 times 1. Now, alin ba dyan ang pwedeng i-cancel? 3 times 2 times 1 is 6. Cancel ko si 6. Si 2 times 1 is 2. Pili ka dyan kung saan mo pwedeng i-cancel si 2 times 1. Ang 2 times 1 is 2, so cancel natin sa 10, magiging 5 na lang ito. Kung nahihirapan kayo mag-cancel-cancel, pwede nyo yung idiretso sa calculator. Pero kasi 10 hanggang 1, napakalaki niya na number. Now, ang natira sa numerator are 5 times 9 times 8 times 7 times 5 times 4. Tapos wala nang natira sa denominator. So wala na tayong ilalagay na denominator. So to simplify, 5 times 9 times 8 times 7 times 5 times 4, that is 50,400. So meaning there are 50,400 permutations. Meaning, pwede mo itong i-arrange or i-rearrange ng 50,400 ways. Pwede mo yung baliktad doon na statistics. Pwede mo i-rearrange ang letters yan. 50,400 ways. That is for distinguishable permutation. Now, another example, halimbawa ngaya, mathematics. How many number of permutation of letter of the word mathematics? Now, ano yung mga naulit? We have M. We have dalawang M. We have dalawang A. We have dalawang T. Ano pa? Wala na ata. Yan yung mga naulit. Now, how many permutations are there? Distinguishable permutation ang gagamitin natin kasi may mga naulit na letters or object. Now, bilangin lahat ng letter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 over 2 factorial, 11 factorial over 2 factorial times 2 factorial times 2 factorial. So, this is equal to 11 times 10, 9, 8, 7, 6 times 4 times 3 times 2 times 1. So, yung 2 factorial, 2 times 1 times 2 times 1 times 2 times 1. If you're going to simplify yung nasa denominator, 2 times 1 times 2 times 1 times 2 times 1, 2 times 2 is 4 times 2 is 8. Cancel natin ito, cancel natin si 8. Kasi yung denominator is just equal to 8. So wala na si 8 sa numerator. So 11 times 10 times 9 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So ito yung isi-simplify nyo sa calculator. So ito, mag-calculator na kayo nito kasi very large na ang number. Pwedeng gumamit ng calculator. So hindi ko na i-compute. Kayo na mag-compute sa calculator. So this is distinguishable permutation. Okay, circular permutations. From the word circle, it refers to the different position, arrangement of an object in a circle. So ginagamit natin ang circular permutation if you are going to arrange the object in circular manner, pabilog. The number of permutations P of n objects around a circle is given by permutation is equal to n minus 1 factorial, where n is the total number of objects. Again, ginagamit ang circular permutation if you're going to arrange the object in circular manner. Okay, example. Okay, ito. Due to the increasing number of COVID-19 active cases in Legazpi City, Mayor Noel Rosal called for a press conference for safety reminders and announcements to all Legaspeño. This was attended by 8 media men from different TV and radio stations such as GMA, DCGB, Bomboradio, DWZR, DWRL, Sagitsid, Idol F, News FM, and Sigaw News FM. Following the IATF protocol, these media men were not allowed to go closer to the mayor, and they are seated a meter apart from each other in a big round table. Yan, pinatukaw, suwalong media men sa big round table. Pag sinabi tang round, pabilog na table. Now, they are arranged in circular manner. In how many ways can these 8 people be seated around a circular table? So since i-arrange sila in circular manner, ang gagamitin natin is circular permutations. Take note, P is equal to n minus 1 factorial. So, to solve, how many people are there? That is 8. Constant ang 1, palaging 1 factorial. So this is P is equal to 7 factorial. How to simplify 7 factorial? This is just 7 times 6 times 5 times 4 times 3 times 2 times 1. Wala tayong ika-cancel kasi wala tayong denominator. Now, to solve, that is equal to 5,040 ways. Or there are 5,040 arrangements. This is for circular permutation. Okay. Example number 6. There are 4 different mathematics books and 5 different science books. In how many ways can books be arranged on a shelf if books of the same subject must be placed together? So, titingnan mo kung what type of permutation siya. Circular ba siya? Hindi naman. Ang tawag doon, distinguishable ba siya? May naulit ba na object? Take note, 4 different mathematics books, 5 different science books. So, walang naulit. So, this is not distinguishable. I-arrange ba siya sa circular manner? Books can be arranged on a shelf. So, hindi man circle ang shelf. So, hindi din siya circular permutation. So, anong gagamitin? Ang gagamitin nyo is yung linear, yung nauna. Or pwede natin siyang gawing fundamental counting rule. Okay. So halimbawa, meron tayo ditong bookshelf meron tayong 4 different mathematics books. 1, 2, 3, 4. Dalawaan dito yung shelf. Meron tayong, sabihin natin math ito, math 1, math 2, math 3, math 4. Meron din tayong 5 science books. 1, 2, 3, 4, 5. Lahat yan science. Science 1, science 3, science 4, science 5. Now, ang condition dito, yung question is, how many ways can books be arranged on shelf if books on the same subject must be placed together? Meaning, dapat magkakasama si math, lahat ng math, or magkakatabi lahat ng math, magkakatabi lahat ng science. How many ways are there? So, ang gagawin nyo, paano nyo ba siya i-arrange? Pwedeng, nandito si math, pwedeng nandito part si science. Pwedeng nandito si science sa left side, pwedeng nandito si math sa sa right side. So, meron kang 2 choices. Pwede mong pagbalik ta rin si math and si science. That is, okay, 2 subjects. You are going to rearrange the 2 subjects. That is 2 factorial. Subject muna tayo ha, yung math and the science. Now, kay mathematics naman, for maths, pwedeng ganito ang arrangement. Pwedeng andi dito si 4, pwedeng andi dito si 1. Another arrangement. Pwedeng andi dito si 4 followed by 3 followed by 2. And so on and so forth. Madaming arrangement. Now, in how many ways are you going to arrange this math? So that is 4 factorial since 4 sila. Science. Meron tayong 5 science books. So, pwedeng ganyan yung arrangement. Pwedeng andi dito si 5, pwedeng andi dito si 1. Another arrangement, pwedeng andi dito si 4, pwedeng andi dito si 2. So for 5 science books, you have 5 factorial. Now, ilan lahat? For this kind of problem, the permutation is equal to yung dalawang subject, permutation of the 2 subject, times permutation of the number of books, yung math book, times kung ilang science, factorial. So this is equal to 2 factorial is 2 times 1, 4 factorial is 4 times 3 times 2 times 1, 5 factorial is 5 times 4 times 3 times 2 times 1. Total permutation is, kung isi-simplify sa calculator, this is 5,760 ways. There are 5,760 ways that you can arrange the books in a shelf of the same subject. Dapat magkakatabi si math, magkakatabi si science. Pwedeng baralanggado ang math, basta magkakatabi lahat ng math. Pwedeng baralanggado si science as long as magkakatabi lahat ng science. Pwedeng dito sa left side si science, pwedeng sa right side si science. So all in all, 5,760 ways. Okay, next. 5 couples want to have their pictures taken. In how many ways can they arrange themselves in a row if couples must stay together? So, 5 couples meaning 10 persons. Halimbawa, meron tayo dito, ito, si couple 1. Sabihin natin ito yung male. Halimbawa, dito yung male, dito yung female. si couple 2, couple 3, couple 4. We have here couple 5. So, dalawa. Andito si male, andito si female. Ganito yung arrangement nila. Nasa left side si male, nasa right side si female. Pwede ring magbaliktadan. Andito si female sa left, andito sa right side si female. Si male. So, that is 2 factorial. Itong dalawa, pwede rin silang magbaliktadan. So, 2 factorial. Pwedeng magbaliktaran din si C3, 2 factorial. Si C4, pwedeng magpalitan sila, basta magkatabi, 2 factorial. Si C5, ganun din, 2 factorial. Pwedeng i-rearrange yung mga couples. Pwedeng andi dito si C1, andi dito si C3, si C4, si C2, si couple 5. Pwedeng i-rearrange. Since 5 ito, pwede yan pagbaralang gaduhon. As long as magkakatabi ito. So that is 5 factorial. Kasi 5. 1, 2, 3, 4, 5. The permutation is equal to 2 factorial times 2 factorial times 2 factorial times 2 factorial. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Tapos igapakita ang 5 factorial. So, by simplifying, the total number of arrangement is equal to 3,840 arrangements.